The part 2 of the video, part 1 has already been released, where I talked about the electrolysis, what it means for the electrochemical series. We talked about the cation, the anion. Now, under this channel, we don't like wasting time. We go straight to the point. Under electrolysis, we want to talk about a very important aspect of chemistry that students have a lot of problem in, and that is calculation of what? Electrolysis. The calculation of electrolysis in chemistry. Now, we know that under electrolysis, we have the Faraday's first law of electrolysis, and then we have the second law of electrolysis. We are going to be dissolving both the two laws of electrolysis immediately. Now, we already know from Faraday's first law of electrolysis, we know very well that mass is directly, let me write it as capital M, is directly proportional to what? The quantity of charge. And I will name this my equation 1. I will name it my equation 1. And then, remember that the quantity of charge is current times time. And this is my equation 2. Now, look at what I want to do. I want to remove the proportionality sign, replace it with a constant. And that will be M will now be equal to ZQ. And I will call this my equation 3. Remember that this constant Z is called the electrochemical equivalent or the electrochemical constant. But Q is current times time. So what I'm going to do is I'm going to put equation 2 into this equation 3. So what it means is whenever I see Q in equation 3, I'm going to replace it and put current times what? Time. And then this, my equation will now change to, this will now be Z times current times time. Are you now saying it? And I'll call this my equation what? 4. But the constant I introduced, called the electrochemical constant, is given as relative atomic mass all over number of Faraday times the Faraday's constant. Number of charge times the Faraday's constant. I'm going to introduce it immediately we enter the calculation of electrolysis. Now, I'm going to call this equation 5. Now, look at what I want to do. I want to put equation 5 into equation 4. That's what I want to do. So whenever I see in my equation 5, whenever I see Z, I'm going to replace it with relative atomic mass times number of charges. That is what I want to do. So put equation 5 into 4. It means whenever I see Z, I'm going to represent it with this equation. So therefore, my M will now be relative atomic mass times current times time all over N times F. And that is the equation we need to be solving a lot of calculation. And I'll call this my equation 6. Now look at what I want you to know. Please jot this immediately. The relative atomic mass is also called the molar mass. And the I is the current. Remember, the relative atomic mass is grams per mole, and the current is given, the unit of the current is the ampere, and the time T is in seconds. N is the number of charges, and F is the Faraday's constant. And that Faraday constant is 96500. You're going to see how I'm going to use it. Now, this N is the number of charges here. If I'm talking about copper, the number of charges in copper is 2. If I'm talking about aluminium, the number of charges in aluminium is what? +3. If I'm talking about calcium, it's +2. And that is why in the beginning of this video, at the part 1 of this video on electrolysis, I told you to write this on your jotter, and not only writing it, you need to what? Memorize it. And now, having proved this formula, we are going to enter into the word proper on the other example that are going to follow. Remember also that the quantity of charge Q is given in coulombs. The unit of the quantity of charge is what? Coulombs. We're going to start solving an example right away. It's gonna be one of the most amazing videos you have ever watched on this channel. We have an example at the board. A copper sulfate solution is electrolyzed using a platinum electrodes. A current of 0.193 amperes is passed for 2 hours. How many grams of copper are deposited? Now, look, your relative atomic mass of copper is already given. And then your Faraday constant is also what? Given. This is so, oh my God, this is a bomb. When you ever see this question in your work and jam, all you need to do is just write this formula that I just proved. That your mass is what? The relative atomic mass times your current times your time all over n times F. Now they are talking about copper. That is why I said you have to cram this thing and the charges. Now you already know from your activity series that copper is what? 2 plus. So your N is equals to what? 2. So you just put it here, your answer will flow naturally. I told you this is a bomb. So relative atomic mass is 63.5. Your current has already been given in ampere, which is 0.193 times your time is 2 hours. Now look at the thing. Your time has to be in seconds. So they gave it to you in hours. So for you to convert your time from hours to seconds, you're going to have to say 2 times 60 times 60. And that will give you 72,000 seconds. So if you want to convert your time, if it's in minutes, you want to convert it to seconds, you times by 60. If your time is an hour and you want to convert it to seconds, you times by 60 times 60. And that will give you 72,000. So this is 72,000. You divide, what is the number of charge of copper? 2. Your F is what? 96,500. If you punch it in your calculator, the answer you're going to have to get is 0.457 grams. Remember, the mass is in grams. In chemistry, we use mass in grams. It's in physics, we normally use our mass in kilograms. How easy can this be, guys? This is so easy. I told you it's going to be so easy. Let's go to the next example. During the electrolysis of a salt metal M, a current of 0.5 amperes flows for 32 minutes. Flows for, there is 4 here, please, for 32 minutes, 10 seconds. And deposit 0.325 grams of M. What is the charge on the metal ion? What is the charge on the metal ion? M is equals to 65. F is equals to 96,500. Now, of course, we have our beautiful formula that M is relative atomic mass times current times time all over N times F. Of course, that is our formula. The relative atomic mass is 65 times the current. Please, this is a bump. You can see that the current is in 32 minutes, 10 seconds. It's so simple. Now, look at what you need to do. It's time for me to clean this. By now, you're supposed to have written it on your jotter. So this is 32 minutes. 32 is in minutes, so you times by 60. And then whatever answer you get, when you times 2 times 60, you'll get your answer in seconds. And then what you are now going to do is you now add it to the 10 seconds. Because this seconds is already in seconds, so we are not actually converting it. And then once you time 32 plus 60, and then you add it to the 10 seconds, you're going to get a time of 1,930 seconds. So this plus this times this plus 10, you get 1,930 seconds. And that's how to convert it. So this will give you 1930 times so a current of this, so your current is 0.5 divided by, now they are talking about the element M. They want you to get the number of charges, which is the N, but they are giving you the mass to be 0.32. So N is what we are trying to find, and this is 96,500. So remember that your M, which is 0.325, is equal to 65 times 193 times 0.5 all over N times 96,500. Are you seeing it? Now, I want to make N the subject of the formula. So all I have to do is cross multiply. Remember, this is all over 1. So if I cross multiply, this is going to be, you cross multiply here, you see that your N is equals to 65 times 1930 times 0.5 all over 0.325 times 9650. And if you punch that answer in your calculator, you will get a value of, and this will give you, your N value will be equals to 2.0. And that will be your value of N. This is so easy, guys. If you are not writing this on your jotter, I don't know what to do. You have a second example. What current in ampere would deposit 2.7 grams of aluminium in 2 hours? And so all we need to do is write our beautiful formula that M is relative atomic mass times current times time all over N times F. Pause the video, solve it immediately, very fast, get serious. And then they want us to get our current, so and you have your mass, which is 2.7, is equals to 27 times current times, remember, the time is 2 hours, so we are converting. You have 2 times 60 times 60, right? So that will give you 72,000 seconds. All over, aluminium have a +3 charge, so the number of charges is 3 times 96,500, right? Good. So 3 times 96,500. I'm going to make I subject of the formula, and I'm going to start solving immediately. So I from here is 2.7 times 3 times 96,500 divided by 27 times 7,200. So if you punch it in your calculator very well, remember we are trying to make I subject of the formula. Punching it in your calculator, what you will get is a current of 4 amperes. So your current is equals to what? 4 amperes. And that is the answer. This is so easy. I'm going to be dropping a lot of examples on the electrolysis. And every single week we'll be dropping videos. If you are not subscribed to this channel, you are not doing yourself a lot of good. And this is the last classwork. This is a classwork. Endeavor to watch it. Drop the answer for us on the comment section. What amount of silver is deposited when a current of 2 ampere is passed through a solution of silver salt for 193 seconds? So all you need to do is impute your formula and answer will flow naturally. This is all there is to part 2 of this video. I will meet you in part 3 and part 4, where I will be talking about the second law of electrolysis, the calculation involved. And from there, I will proceed to talk about other a law how the elements are deposited during electrolysis. Thank you very much. Endeavor to subscribe.